Right, so in this diagram, we have two triangles meeting up at point F, which could be relevant to us later. We see our given information says that the two triangles are right triangles, and really something that they should have mentioned was which angles are the right angles. Um, and in that case, that's going to be angles E and G. Maybe it's safe to assume that here, but we have a good practice of not assuming right angles just by looking at a picture. So I'm going to go ahead and provide to you that these two are your right angles. Okay, and remember, right angles are congruent to each other. So we also have a given piece of information that says EG and DH bisect each other at F. And so what that means is these two segments are cutting each other in half, meaning they are both being broken into two equal pieces. So look at this proof. Really, the first statement doesn't do a lot. It just writes down this given information and just says that was provided. That's stuff we wouldn't know unless we were told. But because we're told that information, we now know two other things. We know that segment DF is congruent to segment HF. So DF here, congruent to HF here. All right. And that segment EF is congruent to segment GF. So here's EF and here's GF. The reason is not given. We weren't told that these segments were congruent, but we did see that special word bisect. And remember that bisect means to cut in half. And now this is a little different. We haven't seen it ever listed as two segments bisect each other, but that is exactly what's happened. DH and EG have bisected each other, and so both segment DH and EG were cut in half, broken into two equal halves, as we see in our picture. So our reason is simply going to be definition of segment bisector. Okay. And for some reason, that's enough information to say the two triangles are congruent. And if you look, the theorem, it looks like we have an angle and two sides marked, which would be side-side angle. And that is not a theorem that we have. But we had a fifth theorem that applies specifically to right triangles. And that theorem was called hypotenuse leg. And if you recall, what that means is both triangles have a hypotenuse that is the same length, and they both have a leg that's the same length, such as this one here and this one here. And through Pythagorean theorem, that means the last pair of sides are also going to be congruent, meaning the triangles are congruent. So hypotenuse leg, it applies to right triangles if you know the hypotenuse is the same and the leg is the same. And after that, since you know the two triangles are congruent, what does that mean? It means all angles and all sides are congruent. And so again, you can clearly see here that D is listed first for this triangle, H is listed first for this one. So yes, angle D would have to be congruent to angle H. And that's our reason that we've been putting as CPC TC.